in computational fluid dynamics, what we do is that we convert PDEs into a set of algebraic equations. A set of algebraic equations. The method of converting PDEs into a set of algebraic equations is known as discretization. Discretization. And we have many different techniques available to us for discretizing a PDE into a set of algebraic equations, such as finite difference method, in short known as FDM. We have finite volume method, in short known as FVM. We have finite element method, in short known as FEM. Among these three, the finite difference method is the most intuitive one. It is the most intuitive one and it is simple to understand. But in computational fluid dynamics, finite volume method is the most commonly used technique to discretize the PDEs into algebraic equations, and most of the softwares such as Fluent, ANSYS Fluent, or OpenFOAM, these are all based upon finite volume methods. In CFD, finite element method is not much used. It is mostly used in structural mechanics. So among these three, in CFD, mostly these two are used, and we will be focusing today on finite difference method, or FDM. So basically the challenge is to convert my PDEs into algebraic equation. Suppose we have an equation for general transport equation. Suppose we have a PDE for general transport equation, that is dou phi upon dou t plus of u, that is x direction velocity. This will be my dou phi upon dou x plus v. This is my y direction velocity, dou phi upon dou y plus of w, dou phi upon dou z. W is my z direction velocity. This is diffusion constant multiplied by dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square plus s phi. This is my transient term, this is my convective term, this is my diffusion term, and this is my source term. This is my source term. This equation is nothing but general transport equation. If we substitute T or temperature in place of phi, we will get energy equation. If we substitute U in place of phi, we will be getting x direction momentum equation. If we will be substituting V, we will be getting y direction momentum equation. If we will be substituting W, we will be getting z direction momentum equation, and so on and so forth. Now suppose somehow we know these values, we know the value of velocities, we know the value of diffusion constant, we know the value of source term. Now the challenge is to obtain the values for these differential equations, these differential terms, d phi upon dt, d phi upon dx, and dou square phi upon dou x square, and all these terms. So we will use the technique of finite difference method to get to these values. Now my finite difference method is based upon something known as Taylor series expansion. Taylor series expansion. What is Taylor series expansion? Suppose we have a line something like this, and we have discretized this domain in something like this, and we have a point P, we have a point E that is east to point P, and we have a point capital W that is west to point P. This is my positive x direction, and suppose the distance between P to E is delta x and W to P is also delta x. Now suppose we want to know the value of phi E in terms of phi P. So from Taylor series expansion we can write phi E is equal to phi P plus of delta x divided by 1 factorial multiplied by dou phi upon dou x at point P plus delta x square divided by 2 factorial. This will be dou square phi upon dou x square at point P plus of delta x cube divided by 3 factorial. This will be multiplied by dou q phi upon dou x cube at point P, and so on and so forth. So this is from Taylor series expansion. Now in similar way we want to know phi w. So how can we get phi w? So in terms of phi p and the values at phi p at the values at point P. So this will be equal to phi p plus of, now my west point is located backward, my west point is located in the backward direction. So my delta x value will be negative. So this will be minus delta x divided by 1 factorial. This will be dou phi upon dou x at point P plus dou x square at by 2 factorial. This will be minus delta x, but because it is square this will be converted to plus delta x square. This multiplied by dou square phi divided by dou x square at point P plus of minus delta x cube divided by 3 factorial. This will be multiplied by dou q phi upon dou x cube at point P plus so on and so forth. Now suppose this is my equation 1, this is my equation 2. Now suppose I want to find the value of dou phi upon dou x. Now the task is to find the value of dou phi upon dou x at point P. Now suppose this term is unknown. So what we can do is that we can simply, using equation 1, so in the first case I am using equation 1 to find out the value of dou phi upon dou x at point P. This is equal to, I will take my phi p to this side, so this will be equal to phi e minus of phi p. Now this term is multiplied by delta x, so this will be divided by delta x minus of, all these terms will go to the left hand side. This will become, and it will be divided, all these terms will be divided by delta x. So this will be equal to delta x square by 2 factorial, and this will be divided by delta x. This is dou square phi upon dou x square at point P plus, or this will be x cube divided by 3 factorial divided by delta x dou q phi divided by dou x cube at point P, and so on and so forth. Now what we will get is that dou phi upon dou x at point P, this will be equal to phi e, sorry, this is phi p, phi e minus phi p divided by delta x minus of delta x divided by 2 factorial. This is dou square phi upon dou x square, this is at point P, and plus this terms will be delta x square divided by 3 factorial and other terms. Now I want you to focus on these terms. So the order of magnitude of this term will be delta x. Why this is so? Because suppose my delta x is equal to 0.01. So the value of this term will be nothing but 0.01, this will be nothing but 0.01 multiplied by sorry, this will be simply 0.01 multiplied by other terms. This one will be 0.01 square. So the contribution of this term will be much higher compared to contribution of this term. So we can simply write these terms as equal to order of delta x. This is also known as order of accuracy. Order of accuracy. So finally, let us see what we will get is that we will get dou phi upon dou x at point P. This is equal to phi e minus of phi p. This is divided by delta x plus of order of accuracy, that is delta x. So if in this case the order of accuracy is 1, order of accuracy, this is equal to 1 because here it is raised to power, delta x is raised to the power 1. So we have found out the term dou phi upon dou x at point P in terms of phi e, phi p and delta x, and this is of order of accuracy 1. Now suppose we want to use equation 2. So what was my equation 2? So this was my equation 2. My phi w was written using phi p, dou phi upon dou x at point P. So when we will be doing the similar exercise using equation 2, what we will get is that dou phi upon dou x at point P will be equal to phi p minus phi w, this is divided by delta x plus of order of accuracy will also be equal to 1 in this case because this is raised to power 1. Now suppose what we do is that in third case we subtract. In this case what we do is that we subtract equation 2 from equation 1. So what we will be doing is that we will be subtracting equation 2 from equation 1. So equation 1 minus equation 2, we will be doing this, and what we will be getting is that we will be getting dou phi upon dou x at point P, this is equal to phi p minus phi w, sorry, this will be phi e minus phi w divided by 2 delta x plus, in this case the order of accuracy will be 2. So the order of accuracy will be equal to 2. Now how am I getting this order of accuracy to be 2? So when we subtract equation 2 from equation 1, what we are simply getting is that, let us first try it. So this is my third case. I am subtracting my equation 2 from equation 1. So equation 1 was my phi e was equal to phi p plus of delta x by 1 factorial. This is dou phi upon dou x at point P plus of delta x square divided by 2 factorial. This was my dou phi upon dou x at point P plus delta x cube upon 3 factorial and other terms. My equation 2 was phi w is equal to phi p minus delta x upon 1 factorial. This is dou phi upon dou x at point P plus of delta x square by 2 factorial. This is dou phi upon dou x at point P minus of delta x cube by 3 factorial. This is my dou q phi upon dou x cube and plus of other terms. Now, when we subtract equation 2, this will be minus will be converted to plus, this plus will be converted to minus, this minus will be converted to plus. So what we will see is that these two will cancel out. So we will get phi e minus phi w. This is equal to phi p. Phi p will cancel out. This plus plus, so this will be 2 delta x multiplied by dou phi upon dou x at point P. This will be plus of 2 upon 3 factorial delta x cube into dou q phi upon dou x cube, plus we call this as higher order terms. Now, when we divide the whole terms, when we divide all the terms by 2 multiplied by delta x, what we will get is that phi e minus phi w divided by 2 delta x, this is equal to dou phi upon dou x at point P, plus of 2 by 3 factorial, and in this case this will be equal to delta x square. This is dou q phi upon dou x cube plus higher order term. Now this can be written as order of delta x square, because the lowest term of delta x will be equal to 2. So this is order of accuracy is equal to 2 in this case. Now we have got 3 different ways to calculate the value of dou phi upon dou x. So we have got 3 different ways to calculate dou phi upon dou x. The first one was dou phi upon dou x at point V was calculated as phi p minus phi, this was my phi e minus phi p divided by delta x. Second one was dou phi upon dou x at point P was equal to, this is phi p minus phi w divided by delta x. Third one was dou phi upon dou x at point P, this is equal to phi e minus phi w divided by 2 delta x. This was my first order accurate. This was also my first order accurate, and this one was second order accurate. Now we have computed the value of dou phi upon dou x at point P using point E or point W, or in the last case both the point. Now this was my coordinate direction, this is x positive direction, so this is positive, this direction is positive x direction. So point E is located in the forward direction from P. So point E is located in the forward direction, and in this case to find the value of dou phi upon dou x at point P, we are using the forward point. So this is known as forward difference. This is forward difference or FD. This is my west point. This term dou phi upon dou x is calculated using west point, that is located in the backward direction of the P point. So this is known as backward difference. This is backward difference or BD. Now in this case I have used both the point E and point W, and my point P is located centrally to these 2 points, so this is known as central difference. This is central or CD. Now we have calculated dou phi upon dou x at point P using 3 different methods, but we have seen in our general transport equation that we have second order terms also. So here is our general transport equation, and we have second order terms also. So we have d dou square phi upon dou x square, dou square phi upon dou y square, and dou square phi upon dou z square. We have seen how to calculate the first order term, dou phi upon dou t, dou phi upon dou x. So all these terms can be calculated using finite difference method, but we still have to see how to find out these terms, dou square phi upon dou x square and all the other terms of the second order. So let us do that. Now we will be finding out the value of the values of dou square phi upon dou x square. So this will be, the aim is to find dou square phi upon dou x square at point P. So how we will be doing is that this is the unknown. Now again, this is my point P, this is my point E, and this is my point W. So now I have written my equation, that is phi E was equal to phi P plus of delta x by 1 factorial multiplied by dou phi upon dou x at point P plus of delta x square divided by 2 factorial dou phi upon dou x at point P. This is dou square phi by dou x square, plus I have higher order terms. In the similar manner, we will be having phi w, this is equal to phi p minus delta x upon 1 factorial, this is dou phi upon dou x at point p minus, no, this will be plus delta x square by 2 factorial dou square phi upon dou x square. Let us write one more term, minus delta x cube divided by 3 factorial, and this is dou square phi by dou x square, plus I will have delta x to power 4 factorial, and we have other terms. Now in central difference, to find out dou phi upon dou x and the central difference, we subtracted equation 2 from equation 1. In this case, we will be adding these equations. So we will simply add. So if we will be adding equation 2 to equation 1, what we will get is that phi e plus phi w, we will get phi e plus phi w, we will get phi p plus phi p, that is 2 phi p, and these two terms will cancel out each other. Then we have delta x square, this will be have delta x square multiplied by dou square phi. These are half terms, so this will make a full term if we will add these two together. This will be equal to dou square phi upon dou x square at point P, plus these terms will cancel out, and the next term will be my delta x to the power 4 divided by 4 factorial, and we will be having dou to the power 4 to pi of phi divided by dou x 4 at point P, and we have other terms. Now we divide by delta x square, so we will be getting dou square phi upon dou x square at point P. This is equal to phi e plus phi w. This 2 phi p will go this side, so it will become minus 2 phi p. This is divided by delta x square. Now this will be order of accuracy of delta x square, because I am dividing this by delta x square. So this is delta x to power 4, so when it will be divided by delta x square, it will become delta x square. So the order of accuracy will be equal to 2. So now we have got the value for our term dou square phi upon dou x square at point P. So let us write this. So we have got dou square phi upon dou x square at point P. This is equal to phi e plus phi w minus of 2 phi p divided by delta x square, and the order of accuracy is delta x square, or order of accuracy is 2. Now again, this is central difference. Why? Because we have used both the points, point E and point W, to calculate the value of dou square phi upon dou x square. So this is my central difference.